Well, hello. I was asked about solving systems of equations when we have two equations that have some fractions in them. I was given this particular example by someone who stumbled across my original solving systems video and said they were having a little bit of difficulty with this one. So let's go through and I'll show you what I would do here. Now, we can work with fractions, but in equations, it's actually easier to get rid of them completely. And I'll show you what I mean by get rid of them. If I had just a simple fraction 2/3, if I were going to multiply 2/3 by any number I wanted to, I would pick something that 3 went into. Because if I pick something that the denominator goes into, like say 12, then my final answer is going to be a whole number. So I would do 12 times 2 to get the top, and remember the denominator there is 1, and so to multiply fractions we multiply numerators and multiply denominators. So this is 24 divided by 3. And 24 divided by 3 is just simply 8. 3 actually goes into 24. And the reason 3 goes into 24, which is the number we got when we multiplied 12 by 2, it's because 3 actually goes into 12. In fact, I could have gotten to 8 a little quicker by saying, well, 3 goes into 12 4 times, and then actually multiplying the 4 by the 2 to get my 8, rather than doing the multiplication and then the division afterwards. So this is a canceling effect. And this is actually what we're going to do to get rid of the fractions entirely. And I'll just get rid of that. So we're going to get rid of the fractions. I'm going to change my color of my pen here to get rid of the fractions. Since I want to get rid of fractions that have a 2 in the denominator and that have a 3 in the denominator here, the number I'm going to have to multiply by has to be divisible by both 2 and 3. Now you can pick any number that's divisible by both 2 and 3, but usually we're going to want to take the smallest one. And the smallest number that both 2 and 3 go into is in fact 6. So what I'm going to do is multiply the whole equation, both this side and this side, by 6. And when I do that, I multiply each group of things that's linked by multiplication. So this thing has a group and this thing has a group, and then on this side I only have the 2. So I'm going to multiply this whole group of stuff by 6, and I'm going to multiply this whole group of stuff by 6, and then I'm going to multiply this side by 6. Okay, so we want to multiply everything that's kind of separated by this plus sign, every block of things that's separated by a plus or a minus, we're going to multiply by that number. So this is what happens now. This 2 goes into the 6, and I'm left with a 3. This 3 goes into the 6, and I'm left with a 2. And then over here, there's no division here because there's no denominator. So this side is just going to be 2 times 6. So what I'm going to get down here, and I'm just going to put 1, and we're going to do a bit of simplifying here, is now I do 3 times 1, which gives me 3, and then I have to multiply that 3 into this bracket, but I'm going to do that in a couple of steps. So 3 times 1 gives me 3, and then I have this bracket, x minus 1. And over here, 2 times 1 gives me 2, so I have to go plus 2, and then I have this bracket still. We're going to deal with that in the next step. And then on the other side, 2 times 6 is 12. That's pretty straightforward. So now what I'm going to do here, this has become a lot simpler because I no longer have the fractions to deal with. I just have some brackets and some multiplying. So I'm going to use the distributive law to go through the brackets here, and I get 3x minus 3. And I'm going to use the distributive law to go through this bracket, which gives me 2y plus 4. And this side has nothing to do, so we're just going to leave it as 12. Now over here, I've got the negative 3 and the positive 4, which when those go together, I'm going to get 3x plus 2y. A negative 3 and a positive 4 gives me positive 1. Still nothing to do on that side, so I'm going to leave it as 12. And then this one, I want to get all the letters on one side and the numbers on the other side to start with. So I'm going to subtract this 1 on both sides. Just put a little -1, -1. And so this gives me 3x plus 2y equals 11. Now, here is a better equation to work with than what we started with up here. It looks a whole lot simpler to have 3x plus 2y equals 11 than this. And they actually, it's the same equation. It's just been rearranged and multiplied on both sides so that I get another true equation that is just a whole lot simpler to do. Now I'm going to do the same thing with this one here, except this time, take a look, we've got a 2 as our denominator and a 4 as our denominator. So I want the smallest number that both 2 and 4 go into. Well, that happens to be 4. And remember, I want to multiply each block of things. This is basically the distributive law. I'm multiplying both sides by this number. But when I multiply both sides, we only need to multiply the blocks of multiplication. So this gets multiplied by 4, and this gets multiplied by 4, and this over here also gets multiplied by 4. So now remember what we did before. We made our cancellations in here. We've got 2 goes into 4 2 times, and then I just do 2 times 1 times x. So down here I'm going to put equation 2. And so I have 2 times 1 times x, which is just 2x. Then this 4 goes into this 4 one time, and I'm just left with -1 in front of this bracket. So -1 y minus 4. And on the other side I have 16. Now this isn't quite as complicated as what we had up here. We can kind of deal with it fairly quickly. That's going to give me 2x. This -1 is going to go through the bracket, so I have -y plus 4 equals 16. And then I only have this +4 on this side. Remember, it's +4 because I did the distributive law here. I did -1 times -4 gave me +4. So I'm going to subtract 4 on both sides. So I have 2x minus y equals 12. Okay, now let's just extend that page. And again, this looks a whole lot simpler than what we started with. So I'm going to call these two equations something different because they're not 1 and 2 anymore because we've changed them. Let's call them 3 and 4. Now, if you'll notice, equation 4 has a variable that doesn't have a coefficient. So if we're going to solve by substitution, that's where we want to start. I want to get that y completely by itself. So I'm going to say isolate. I'm just going to write down what I'm doing so you can look back at it. Isolate y in equation 4. So here's our equation 4. 2x minus y equals 12. And I'm going to subtract 2x on both sides. So when I subtract 2x on both sides, I get -y equals 12 minus 2x. Now remember, we don't want -y, we want y completely by itself. So if I get y completely by itself, I have to multiply both sides by -1 so that I get +y on this side, but that's also going to give me -12 plus 2x on that side. So this is now going to be my equation 5. So you can see we've got more equations that we're working with here than we did in a bunch of the, when we did just straight substitution. So I'm going to take now my equation 5 and sub it back into 3 because 3 I didn't work with. I was working with 4. See, I was working with 4. So now I'm going to take 5 and sub it back into 3. So we're going to say sub 3 into 5. So sub 3 in 5. Oop, wait a minute. I said that backwards. Sub 5 into 3. We're going to take our equation 5 and put it back into equation 3. Now, equation 3 said 3x plus 2y equals 11. And since I got y by itself, in this equation, then I'm going to write down 3x plus 2. It's y that I have something new for, so I'm going to leave my brackets there, equals 11. And in those brackets, I'm going to get minus 12 plus 2x. So now let's multiply this 2 through, and we have 3x minus 24 plus 4x equals 11. The 3x and the 4x will give me 7x, and I still have that minus 24 equals 11. And now we're going to add 24 on both sides. When I add 24 on both sides, I get 7x here, and on this side I have 35. Now that's really nice because 35 is divisible by 7. So when I divide by 7 on both sides, I'm going to get x equals 5. So that seems like a lot of work, but the fractions did add a fair bit of stuff in there, and getting rid of them and simplifying. This wasn't a very easy question. Okay, we're not quite done yet though, because that gives me my x. I still have to find my y, and we're going to do it the same way as we did before. I'm going to take this x equals 5 and sub it back up into this equation. So I'm going to say sub x equals 5 in equation 5. So y equals negative 12 plus 2 times 5, which is negative 12 plus 10, or negative 2. So our final answer is x equals 5 and y equals negative 2. And I hope that helped you out. Thanks. Bye.